Eighth grade. Today we're going to continue our unit on chemistry. Our topic for today is ionic bonds, and our essential question says, what happens to electrons during an ionic bond? So let's go ahead and get started. Okay, chemical bonds. A great way to think of this is atoms joining together. They have a strong attraction to each other. So how does this happen, and why does this happen? Atoms bond with other atoms that allow each to become more stable. So that explains why they're trying to become stable, right? Atoms want to be stable, but sometimes they can only do that with the help of another atom. So that still doesn't tell us how. Let's keep reading. Atoms form bonds by using electrons in their outermost energy level. These electrons are called valence electrons. So there's a key word right there, valence electrons. Your valence electrons would be just those electrons in the outermost energy level for a particular atom. Those are the only ones that we're going to be worried about right now, because only valence electrons will be able to bond with another element. So it's really important that we know how many valence electrons a particular atom has. Okay, we can illustrate how many valence electrons an element has through a dot diagram. An electron dot diagram is the symbol for the element surrounded by as many dots as there are valence electrons. So if you look at the periodic table to the left, it looks a little different than what you're used to. That's because this is just elements 1 through 20, so we're missing a whole bunch of them. These are the ones that we care about right now. Each symbol is surrounded by dots. And if you count up the dots, that will tell you how many valence electrons that particular element has. So remember, the goal is to be stable. If you look on the right-hand side, you'll notice that helium, neon, and argon, they are all noble gases. They're full. They're stable. They can't fit any more electrons. Remember, helium only has one energy level. That's why there are only 2 electrons. But neon and argon, they are both full. They have all 8 electrons, so they can't fit any more. If you look on the other side of the periodic table at your alkali metals, they each have only 1 electron. That's it. Just 1 electron in their outermost energy level. They're going to try to get rid of that electron, because sometimes it might be easier to lose an electron than to try to gain like 7 electrons to become stable. So let's talk about what this is called. This would be called an ionic bond. An ionic bond involves the complete transfer of valence electrons. One atom loses an electron, and the other atom gains an electron. So this would be the situation that we have with sodium and chlorine, for example. Now, at the top, we have a Bohr model version of what an ionic bond would look like, and I think you'll agree the dot diagram is a little bit more user-friendly. We have sodium here with 1 valence electron. Chlorine has 7 valence electrons. Instead of sodium trying to gain 7 new ones, it would be so much easier for him to just give away an electron to chlorine. And now look at that. They're both stable. Now you'll notice there's a plus sign next to sodium and a negative sign next to chlorine. That's because they're ions. Because sodium gave up an electron, it is now more positive than it normally would be. And since chlorine gained an electron, it's now more negative than it normally would be. And together, sodium and chlorine are sodium chloride. That would be a compound of table salt. All right, that's it for today. Go to Google Classroom, answer your question of the day.